I talked a little bit about the different types of pumps. Positive displacement, I think I used the term piston pump, and that's what we're looking at here. These are only going to be on shallow wells. I want to say that I'm going back to my drive the fire engine days. Mathematically, I think, when we draft from rivers or draft from ponds and such, we can lift water mathematically 34 feet. And that's with the fire engines and the piston pumps being able to pull these things up. I have never known anybody who was able to lift water that much. We're not really supposed to be even trying to lift water more than 20 feet. So if we're 20 feet higher than the riverbed or anything with it, then that's going to create a problem. But the good news is with positive displacement pumps, you are actually able to siphon. You're pulling water out of there, and then you're able to push it out. It's a specific amount of water for each stroke of that piston. It's going to be a specific amount of water that's going to be moving. All right. Going to the left side, the centrifugal pumps, the water comes in through the eye. So as we're looking on the left side of the drawing, the pipe that goes up and down and goes right into the middle, that's what brings the water in. All right. And as that water comes in, and that has to be filled up completely with water. This is not an airtight chamber. It cannot pump air through a centrifugal pump. A positive displacement pump can pump air, but a centrifugal pump cannot. So that has to be filled up with water, or water has to be pushed into it some way or another. It has to have a little bit of pressure to go ahead and get the water in it. Then the impellers start spinning, and when they spin around, they push the water to the outside edges, and then the opening at the top is where the pressurized water is going to come out of. Now, these centrifugal pumps can build on each other. So if I have a 500-foot well, I might have 4 pumps in there. All right, one is going to be all the way at the bottom, and then maybe every 100 or 200 feet, depending on the size of the pump, they're all going to kick on, and they're all going to take their turns moving the water up the line so we can get it to where we use it. I do want you to know the difference between a centrifugal pump and a positive displacement pump. A positive displacement pump can pump air. A centrifugal pump cannot. A positive displacement pump has a defined amount of water that moves for every stroke that it makes. A centrifugal pump creates pressure. So if I put these in multiple alignments, or basically in series, I can increase the pressure and increase the flow when it comes to it by putting them in line with each other. I couldn't do that with a positive displacement pump or a piston pump. Water shutoff, going through the main components. This is typically what we're going to see when we come into a house. We want to identify the water as where it comes into the street. That's our supply line. The state of Illinois SOP says that we have to identify where the water shutoff is. Most people will take a picture of it, say it's in the basement, north wall, whatever. I don't think they need you to put a measurement down and say exactly where it is. Just give a rough idea is fine. Where are we at here? Number 1, we're working our way from the house out. So let's start with number 5. That's a copper service feed. Number 6 is, it says here that's the backup shutoff valve. And I don't think it is. I think that was the primary one that was installed there. Now these gate or globe valves that you see there, anything that you have to twist like that, I would never touch that thing. In fact, I try to avoid turning any valve. Typically they're one-timers. I would explain this to my client as well. If there's an emergency and you have to turn the water off, this is one of the locations where you could do that. Number 7 is also a shutoff valve, but that's a ball valve, and we'll talk about that in a minute. These gate and globes, they're notorious for leaking, especially if they've never been used for years. When I turn it off and open it up, they're just notorious for leaking. I don't know any other word to say it. But now if this is leaking and I have to replace it, the only place I could turn the water off to this house is out in the street. And I need one of those Buffalo box keys in order to do that. So I would have to get the water department out here or a plumber that has one in order to shut that water off and replace that valve. Ball valves, don't get me wrong, they do leak, all right? But for the most part, I have a lot more confidence in these than I do any one of the gate or globe ones. Then we work our way to the water meter. In our area, it's very common that they put tamper wires. And if you look pretty close, I thought this one was cut, but you could... Yeah, I'm not just really seeing it. The only thing I'm seeing on this one is the cable that is for the meter reader from the outside. But typically there's a tamper wire. Just by the off chance, maybe about 10 years ago, 15 years ago, I just saw one that was sticking up and loose and it was cut. And it just caught me by surprise, right? So then all of a sudden I started looking at these tamper wires on every inspection. And I got to say, I was actually surprised that I've been finding maybe 10, 15% of them that are actually cut. And something needs to be, that could end up being a $500 fine. So with a lot of these communities, to me, that's a big deal. So I usually advise my clients when I see those tamper wires cut that they contact the local water authority and let them know that it is. I know there's some communities, like Northbrook, for example, where I used to work, they don't put the tamper wire in anymore, and they don't put that tag. But Wilmette, where I live, we just had a new water service put here. Sure enough, the tamper wire's on there, and there's a nice tag on it that says this is a $500 fine if you remove it. People do keep the original pipes, and they can take that water meter off if you got a shut-off valve on both sides. Put the new pipe in there, and you're not going to be paying a water bill for a while. Now, please don't take what I just said as me encouraging you to steal water. We don't want to do anything illegal. But we also don't want to be accused of doing anything illegal, nor would we want our clients to be accused of it. So we'll bring it to their attention, let them know what it is, and whatever decision they do, they can do from there. All right, so here's our big famous warning. Don't turn on or off a main water or any shutoff valve whatsoever. They leak. That's the bottom line. You're not going to want it to leak. They're going to leak. And the finger's going to be pointing at you. So make sure that we get everybody clear, all of our clients, real estate agents, everybody know. Valves are there for an emergency. And it is common that they leak. We're not going to go ahead and create a problem by testing these valves and finding out if they leak or not. If somebody else wants to do it, let them do it, but it's not going to be done by me. Supply lines. So again, they're copper, plastic, galvanized. Those are pretty much the most common ones. I don't think we use too much lead for our supply lines in the house. So we talked about service. Now we're going to talk about supply. Again, this is the stuff that's after the water meter. Black iron, that's typically used for gas pipes. We really don't want to be using iron. It rusts, it corrodes, it's pretty bad. I've seen this rarely on galvanized homes. Somebody must have had a leak, or maybe it was corroded real bad and they replaced a section of the galvanized pipe. They didn't know better, so they purchased black iron fittings, black iron pipes, and since everything's screwed together because it's the same pipe thread, they figured that it was okay when really it isn't. All right. Galvanized has been common, even though it rusts and corrodes to the inside. It does have the same threading, but that's something that's been time tested for a long periods of time. But it does have a shortened lifespan. That's 60 years. This is a water supply line, and you can see the black pipes on there. Those are the black iron pipes, where the more grayish ones are going to be the galvanized. So cast iron, black iron, and galvanized, those all corrode from the inside out. So when I start seeing circles and rings like we're seeing on the galvanized pipes on these here, that's an actual leak. All right, it corroded on the inside. That's where it's the worst. And now it's working its way to the outside. Even any sort of stalactite or stalagmite, any sort of dripping that I see there, even if it's dry, the only way for that dripping to get there was for water to be there. So it's common that they'll start leaking like a little pinhole leak, and then they self-seal and they stop leaking. And then they'll leak again, then they'll stop leaking again. It's very common. Um, I have never tried this to see if it's true, and I don't have the nerve or guts to try it to see if it's true. I just tell people, and they tend to believe me, like I believe the person who told me this. But when I see stuff like this on here, if I take a knife and I start scraping at it, it's pretty much guaranteed that I'm going to be able to make that leak. All right. So it's not something that, we want to put our hands on and start rubbing and see if we can clear it away to see the condition of the pipe. Once we clear it away, it's going to probably be leaking. All right. So I would avoid it. When I want you to get out of this slide, galvanized pipe, black iron pipe, they corrode from the inside out. And this is what it looks like. Copper, I don't think it's in the test that you have to know which pipe is the thickest and which one is the thinnest where it comes to it. For me, I remember it by remembering Martin Luther King. All right. So MLK, M is the thinnest, K is the thickest. I would like you to know the difference between hard temper and soft temper. Most plumbing that we see with copper pipes is either going to be type M or type L. Most underground stuff that you're going to see is going to end up being type K. That's the thickest, and it just can hold up to the most amount of stress. Inside supply lines for copper everything is pretty much hard temper. If you start seeing soft temper where somebody's bending water lines, and I'm talking anything other than like a refrigerator ice maker line, those are typically soft temper copper, so people could feed them through the walls and stuff. But, we're not supposed to take anything soft temper through the walls. But anyway, so it's flexible so that the refrigerator can move, all right? But yeah, inside the house, only hard temper, so it shouldn't be bendable or flexible at all. PVC, CPVC, they're both plastic. They're both designed for potable water. Excuse me. Potable water is, I like to remember the term potable. Somebody from the military said that's exactly where the word came from. You're able to put it in a pot, but it means drinkable. Both of these pipes are for potable water. The only difference between the two of them is going to be what temperature that they're rated at. And yeah, so it's 200 psi, 3/4 inch pipe on the PVC. And I do believe the CPVC is also 200 psi. They are both for drinking water. But I know the CPVC has a higher temperature rating than the PVC. And let me look at the bigger screen here. 200 psi, 23 degrees Celsius, where the CPVC, where's my 400 psi at 70 and 100 psi at 180 degrees. All right, and I don't know where 23 degrees Celsius comes into play on it. I know 100 degrees is 212 and 0 is 32. So that's got to be somewhere in the middle there, obviously, someplace probably around 100 degrees. But since water can be hotter than that, we're not going to use PVC for our hot water lines. You can use PVC for cold water lines, but not hot water lines. Most of the area around here, here being again in the Chicagoland area, we're going to be metallic pipes. There was a time frame where the Illinois Plumbing Code did overrule all the municipalities. I want to say it was like around the 2000s. And even Chicago, up until the end of this year, I think. Or was it the end of last year? No, it was the end of last year. So January 1st. City of Chicago was actually allowing PVC and CPVC in the plumbing. They were doing a test program with it. So you are going to run into these items. And it doesn't necessarily mean that it was against code or somebody tricked somebody or did something wrong. I know other areas further out, these are just very common to see in there, and there's really no problems with it unless the water freezes. But the same thing, whether it's copper or plastic, they're both going to be weak when it comes time to freezing water. I think the only piping that I'm aware of is cross stitch polyethylene or PEX pipe, where that will expand enough that if the water does freeze, it actually won't burst the pipe. I mean, water won't flow, of course, but you're not going to get a broken pipe out of it. With the copper, CPVC, PVC, these are all going to break, and then once that ice melts, you're going to have water spewing all over the place. This is just the basement of a residential building. You see the pipes are white and plastic. Those are PVC. They're using them for the hot side, and that's where our problem comes in. Fine for the cold, not so fine for the hot. All right. Polybutylene, is what we're looking at here. Both comes in stiff and the bendable stuff or the flexible stuff. The only time I really see this being used is on like lawn sprinkler systems. And even that around here, a lot of people still like to go with PVC for their lawn sprinklers. The connections that they had with the polybutylene and ethylene, where the plastic starts to break down or becomes soft, rubbery, is where the temperature rating comes from. All right, Mark, I'm going to put that up on the screen. I think that's a good ad. And, Mark here is pointing out where the plastic starts to break down and becomes soft and rubbery. And basically, it's at its failure point. And that's where the temperature ratings come from. All right. And we don't know how long it's going to take them to do one thing or another. But this is a good ad. Thank you for putting that on there. And just so everybody else can hear this, Mark is turning into my favorite person today. All right, but don't tell him that. All right, where are we at here? Now, polybutylene, there were some class action lawsuits on this stuff. Something to do with the chlorine that was being put in the water. And that chlorine was reacting with the fittings on these things. I know I messed with this a couple times putting them together. And you almost need an actual blueprint to go ahead and figure the order of operations. I mean, once you figure it out, everything's nice and easy. Don't get me wrong. But putting these things in the different pieces in the right orders and the washer in here going in the right different direction. If you got one of these things backwards or put in wrong, then that fitting is going to leak. The good news is it's going to leak right away. And then you're just going to end up, messing with it and putting it in right until you can get it to stop leaking. But I would do a little bit of research on polybutylene and class action lawsuits with it. I think you're going to end up finding it somewhat interesting.